Right. Good evening, everybody. Today I'm starting nuclear power plants. I have stopped with the topic of chain reaction in last class. We will start with the topic of chain reaction here also. Okay. I will explain what is chain reaction in detail. And here until last class, we have come to know what are the basics of nuclear fuels, how many type of nuclear fuels are available. Okay. Even we have come to know about nuclear fission and fusion reactions, how energy is liberated. How association of energy, uh, how uh, how energy liberation is associated with fission reaction, fusion reaction, and how it is happening. How we are calculating the amount of energy which is getting released in fission and fusion reactions. We have come with chain reaction. Why nuclear fuel is why nuclear energy is very emerging. Why we can generate, why we can produce more and more amount of electrical energy means the one important thing, or the important thing which will make generation of more and more heat, it is our chain reaction. So we need to understand what is chain reaction, then only we will understand how this chain reaction is helping this nuclear power plant in generation of electrical energy. Right, let us come to the definition of chain reaction. It is a series of individual reactions in which a reaction of first product produces a second reaction, and the second reaction product produces the third one, and this will continue. What happens is, initially whenever a neutron is bombarded with a uranium atom, the three neutrons will be released, and these three neutrons will again come in contact with three uranium atoms, and totally nine neutrons will get released. Means initially one neutron has turned into three neutrons, and now three neutrons have turned into nine neutrons, and this nine neutrons will turn into 27 neutrons. In this process and in this method, the release of number of neutrons will multiply and multiply, and in each reaction, I mean one neutron, whenever it is bombarding with uranium 235, okay, we are getting three neutrons. Again, that three neutrons are bombarding with three uranium atoms. Like that, for each single reaction, more amount of energy will, heat will be liberated. Okay, so all the reactions whichever are taking place, all the reactions on the right side of the slide, whichever I have shown, that all the uranium atoms, however they are getting bombarded with neutrons, for all this, more and more amount of energy will be released. So this is called as a chain reaction. Right. Next, chain reaction continued. Yesterday I have explained this also in my last topic. Okay. You can observe one uranium atom is turning into three. The black colored small circle is your neutron. Okay. Right. One neutron is turning into three, and three neutrons are turning into nine, and nine neutrons will get turned into 27. And in this manner, the chain reaction goes on and it gets continued. Right. Coming to what is the purpose of chain reaction? The products released in the preceding reaction are utilized for further course of reaction. The products released in the preceding reaction. Right now, whatever the reaction is taking place, the products whichever are released in this reaction are utilized for the further course of reaction. If chain reaction is uncontrolled, what happens? I was telling that chain, because of chain reaction, much amount of heat is getting liberated, and that is the reason that we are able to convert more amount of electrical energy by using nuclear energy. Nuclear energy is nuclear energy's first positive point, or major advantage is more amount of nuclear energy we are able to turn into electrical energy. Okay, right. Coming to some more explanation about chain reaction. What happens if a chain reaction is uncontrolled? If suppose this three have turned into nine, nine have turned into 27. Now again 27 will turn into 81. Similarly, 3 power 4, 3 power 5, and so on it will happen. And it will not stop by its own. We need to stop it. If suppose if you are unable to stop this chain reaction, then that is the example of our nuclear bomb. Okay, even our nuclear bomb, whenever this nuclear bomb explodes or blasts, more amount of heat energy will be released. Okay, and it will cause a lot of damage. Okay, in the surrounding place, on the place where the bomb has exploded, that area will get completely affected. Even whatever the waste which will come out of this nuclear bomb during its explosion, it will cause detrimental effects on environment. Like this alpha, beta and gamma rays, they are very harmful. Okay, even the effect of the people who are staying in and around the area where this nuclear bomb has exploded, that whole area will become affected. Okay, so that is the major drawback, that chain reaction should be controlled. I mean, we should have a setup, or we should have a system arrangement such that the chain reaction should be controlled. At any cost, we should be able to control this chain reaction, is happening which is happening with by using uranium atom. Whichever the chain reaction which is happening, that should be controlled. Okay, if suppose it is not controlled, then it will cause a huge disaster. Okay, even the people, I mean, if it explodes almost the houses and whatever the human and the animal, however the living right the I mean the life of the humans or animals, whatever whoever are living in that exploded area, I mean they will die. The first negative point. The second is, these radiations also will have an effect to the farther places of the exploded area also. And next, the third negative is, and this area will we cannot be used, this nuclear bomb exploded area cannot be used for some years. Why? Because of that radiations. Okay, even whatever the ground or the land where the explosion has taken place, that land also will not be supportive even for production or cultivation for anything. I mean, it will become like a barren land. So, I mean, usage of this chain reaction should be done in a proper manner so that it should not turn into a nuclear bomb. Okay, I think this is one of the example. First, in Second World War, how this Hiroshima and Nagasaki of Japan have got affected till now. I mean, after that explosion, till years they were not able to either live in that area or nothing. I mean, on that land, nothing, neither crops, even nothing was. I mean, a single plant or a single seed was unable to turn into a small saplings. I mean, was unable to give its productive output. Okay, so this is the reason why this nuclear bomb is very dangerous, and why a chain reaction should be controlled in a proper manner. Right, coming to control of chain reactions. See, till now we have understood that what are nuclear fuels, what is fission reaction, what is fusion reaction, and what is chain reaction. Okay, and this chain reaction, I told that it will continue and continue. It will not stop by its own. So definitely, if we are going to, if we want chain reaction to happen by using a uranium-235 isotope, if we want a chain reaction to occur, or if we are conducting a chain reaction by using uranium-235 isotope, then we should be sure that we should be sure that its controlling also should be done properly. So I mean, what is the role of control in chain reaction? Right, how, I mean, definitely we need to control the chain reaction. Right, how do you control chain reaction? So what all should be done in order to control the chain reaction? Let us see. I mean, chain reaction can be controlled using control rods and moderators. Even control by using control rods and moderators, you can control chain reaction. Both are not serving. I mean, both are designed for controlling of chain reaction, but both serve the different purpose in controlling of chain reaction. Right, let us study about moderators and control rods which are involved in our chain reaction, which will help in control of chain reaction, so that more and more energy will get, if we are unable to control, more and more energy will get released, and it will explode like a nuclear bomb. Okay, so how do you control chain reaction? Let us observe. In general, a moderator is a device. The name of moderator only is should give us a meaning that moderation. I mean, it will do some changes. Right. In general, moderator is a device which modifies the system as per the requirement. As per the requirement, moderator is a device which moderates the system. Right. Moderator moderates the system as per its requirement. Right. Coming to moderator in a nuclear reactor. What is a moderator? Normally, moderator is which is acting accordingly for the system to control. Right. I mean, how moderator should be used in nuclear reaction. Okay. What is the importance of moderator in nuclear reactor? Let us observe. It is made of graphite or heavy water material. Okay, moderator is made up of, I mean, the material with which the moderator should be prepared in a nuclear reactor. It should be made up of either graphite or of heavy water. Heavy water is also called as deuterium, which is H2O, whereas our water is H2O. And this heavy water is just nothing but D2O, which is, I mean, hydrogen's isotope is deuterium with atomic number 1 and atomic mass 2. Right. So, I mean, heavy water or graphite acts as a moderator in a nuclear reactor. What does heavy water does? It is mainly used to slow down the movement or speed of the neutrons in the nuclear vessel from 1.5 into 10 to the power of 7 meter per second to 2.2 into 10 to the power of 3 meter per second. Means you should be able to control it. It will slow down the movement. Why? Because this neutrons will move faster and faster, and they will try to bombard on another uranium atom, and they try to, and again one neutron comes and bombards on another uranium 235 isotope, and this will be done within fraction of seconds. It will be done immediately. I mean, it will be done one after the other, one after the other. This neutron will come and bombard the uranium atom, and this will be going on progressively in a continuous manner. Okay, so if we are able to slow down that neutron, then also, I mean, we can then also, I mean, there will be a chance that intensity of the chain reaction will be reduced. Means, I mean, more and more amount of energy will not be released, I mean, within a short period. I mean, energy will be released, but for but in some designed time, or in some designed period only, that amount of energy will be released. So it is mainly used to slow down the movement or speed of neutrons. Means the speed of neutrons whichever are coming out of the nuclear fission reaction, the speed of that neutrons will be reduced. What happens if the speed is reduced? If the speed is reduced, then also this neutron will come and it will collide with uranium 235 isotope. But this process will be done in a larger time. Okay, so liberation of energy, I mean more and more amount of energy will not be liberated. Energy will be liberated, but in some defined time period, this much amount of energy will be liberated. It will depend on the speed of the neutron. The speed of the neutron, it will depend on how we are using moderator. Okay, right. Our moderator will try to slow down the speed of the neutron, which is 1.5 into 10 to the power of 7 meter per second to 2.2 into 10 to the power of 3 meter per second. Means it will slow down the speed of neutrons from 1.5 into 10 to the power of 7 meter per second to 2.2 into 10 to the power of 3 meter per second. Right. Next, coming to what is the principle of moderator. Right. What a moderator is doing, they are showing in a diagrammatic form. Say this is uranium 235 isotope. At the left corner, or at the left part of the slide, you are having a uranium 235 isotope, which is in light blue color. Okay, whenever we are bombarding a fast neutron, okay, fast neutron is usually of 1.5 into 10 to the power of 7 meter per second. Okay, this neutron, after entering the moderator or after moderator's block, this neutron is turned into a slow neutron which is having a speed of 2.2 into 10 to the power of 3 meter per second means a lot of speed difference is there from from a lot of speed difference can be observed in the speed of neutron before the moderator block and after the moderator block. Say in between there is only a moderator block. Here a heavy speed neutron has been changed into a slow moving neutron. So this is our principle of moderator, which they have shown in a diagrammatic form. Right? What is moderator in a nuclear reactor means what all the materials we can use as moderators. See, there are various substances available in nature, but which material or which substance, every substance has its own properties. I mean, based on our requirement, what are the substances which are available for the given purpose we need to understand. So I mean, how a moderator is used, or I mean, a moderator in a nuclear reactor. What is moderator in a nuclear reactor? Sorry, with which material a moderator in a nuclear reactor should be prepared? It is also made with, usually moderators are made with hydrogen, deuterium. Deuterium means the hydrogen isotope of hydrogen. Isotope of hydrogen with atomic mass 2. Next is helium. Okay, next is lithium, next is beryllium, next is boron, and next is carbon. Okay, these all are the moderators. These all are the materials, or these all are the substances which can be used in preparation of a moderator, or which can act as a these are the substances which can act as moderators in a nuclear reactor. See, till now whatever I have told, it was about moderator. A moderator is used in a nuclear reactor to slow down the speed of a fast moving neutron. Okay, it usually slows down the speed from 1.5 into 10 to the power of 7 meter per second to 2.2 into 10 to the power of 3 meter per second. Okay, these are the substances which are suitable for preparation of a moderator, right? What are properties of a moderator means how a moderator should be designed and what are its properties. Okay, properties of moderator, let us observe. Okay, high thermal conductivity. Moderator should have high thermal conductivity means I mean, even though temperature is high, it should be able to move fastly. Okay, it should have high thermal conductivity, at high resistance to corrosion. Even we have learned this in our nuclear fuel also. It should have high resistance to corrosion. Our nuclear fuel also should not get corroded easily. Even if our moderator also should not get corroded easily. Next, the main purpose of a moderator, what is there is, it should be able to slow down the neutrons. It should not absorb the neutrons. Even our nuclear fuel also should not absorb neutrons. Here, moderator also should not absorb neutrons. It should slow down the neutrons. Next, it should be able to slow down the neutrons. It should have chemical stability, means it should not perform any reactions. Okay, it should be resistance to chemical reactions. Like, I mean, it should not perform any reaction with the with whatever the byproducts which are released, or whatever the gases which are there, or inside the nuclear furnace, whatever the material is there, it should not undergo any chemical reaction with that material. Next is, it should have high thermal conductivity. Okay, right. Even for high temperatures also, it should have high thermal conductivity. Next is summary. What all we have read, what all we have discussed in our in our session today. It's a summary I am going to just tell, and I will start with another topic. Till now we have discussed about moderator. It is made up of graphite or heavy water. Okay, it is mainly used to slow down the movement of neutrons from 1.5 into 10 to the power of 7 meter per second to 2.2 into 10 to the power of 3 meter per second. Moderators are made with this type of materials. Already I have told this. Next, I have also discussed about the properties of moderators also. Right, we will go to the next topic, which is working of nuclear power plant and its block diagram. Means block diagram of a nuclear power plant, I mean layout. Okay, that layout we will discuss, and in the layout, what are the components which are involved in nuclear power plant, I mean for generation of electrical energy. whatever we are trying to use in our nuclear power plant, each and every component we will study in detail, right? On completion of this topic, you will be able to know about block diagram of nuclear power plant, working of each module in nuclear power station. Next is what is the importance of graphite as a moderator in nuclear reactor. Right, this is the block diagram of nuclear power plant. Like for we have studied, or we have read about. I mean, sorry, we have I have explained all the block diagrams of all the power plants till now, which I have covered. Okay, like thermal power plant, hydroelectric power plant. Even today we are discussing the block diagram of nuclear power plant. Okay, the first component or the heart of our nuclear power plant is a nuclear reactor. Okay, nuclear reactor is the main component and it should be designed perfectly. Okay, I mean it's designing, okay, and its maintenance is very difficult. I mean, nuclear reactor should be designed perfectly. If it is designed perfectly, only then a nuclear power plant will work properly. Next, if anything happens to this nuclear reactor, the whole power plant will explode, and it will happen like a nuclear, like explosion of nuclear bomb only. Okay, so this is about the block diagram of a nuclear power plant, right? Say in here in a nuclear power plant, what all we are having, I will try to tell. Okay, I mean the black colored small rectangular shaped blocks are uranium, which is our nuclear fuel. I mean isotope of uranium, which is uranium 235. Okay, in between. Right, in between nuclear fuel blocks, we have introduced, kept separators also, separators, or they can also be called as moderators. Okay, means in between the fuel blocks, we have separated the fuel box with moderator, which is of yellow in color, and your nuclear fuel is black in color. Okay, your uranium is separated, your uranium fuel is separated with a moderator. Next, I want to tell that why it is separated with a moderator means whenever you are bombarding uranium atom with a neutron, then 3 neutrons will be released. Okay, why moderator is kept in between nuclear fuel blocks means it will slow down the movement of these 3 neutrons, so that these three neutrons will move slowly and they will go to the next fuel element. Okay, if this moderator is not there, then this chain reaction will occur, it will occur very fastly, and more an amount, I mean uncontrollable heat will be generated. Enormous and uncontrollable heat will be generated in our nuclear reactor. So that is the reason that in between the fuel blocks, I mean you are introducing a moderator which is of yellow in color, right? Next, and the whole setup you are trying to place in a small rectangular block, in a big rectangular block only. I mean, and the ends of this block are lined with reflector materials. Why they are lining with reflector material means, if suppose three neutrons are coming out of the uranium atom, I mean when one neutron is bombarding with the uranium atom. Okay, one neutron is bombarding and 3 neutrons are coming out. If corners of this if the rectangular block, the big rectangular block, if you are not lining with reflector material, what happens is there is a chance that this I mean some of the released neutrons might get wasted, and this reflector material also should not have the capacity of absorbing neutrons. It should only have the capacity of reflecting the neutrons, means the neutron will be reflected back by that material to uh, to the place where the nuclear chain reaction is occurring. Right, on the top of this big rectangular block, you are introducing control rods. Okay, what are control rods? That I will explain after this nuclear power plant block diagram. Control rods are also one Control rod is also one important component of our nuclear power plant, which will help in controlling the nuclear reaction, which will help in controlling the chain reaction whichever occurs in a nuclear power plant, right? The whole setup or the whole furnace is called as a nuclear reactor, right? And this, the walls of the furnace are, I mean, they have shown with black and white, small boxes, meshed boxes. That is lining which we do for our reactor material. The walls of this nuclear reactor will be lined with perfect material, so that whatever the heat which is released inside the nuclear reactor, it should not come out. Means there is a chance that some of the heat might get transmitted or might get spread out of the nuclear reactor. So the lines of the walls of the nuclear reactor will be lined with the perfect material, that heat energy should not come out of the nuclear reactor. Okay, right. And next is, and the material with which we line the walls of the nuclear reactor, it should not absorb the heat energy also. Okay, only it should it should send back the heat energy inside the nuclear reactor only. Right. After this control rods, there is another important block which is called as heat exchanger, HE. Right. What is a heat exchanger? Means here heat will be whatever the heat which is released in our nuclear during our nuclear reaction, from nuclear reactor, whatever the heat which is coming out, that heat should be extracted. Okay, that in order to extract that heat which is getting released from our nuclear reactor, we require a heat exchanger. So heat exchanger is placed immediate to the nuclear reactor. Okay, heat exchanger is placed after nuclear reactor, and and from and from the nuclear reactor's rectangular box, I mean, pipes are connected to our heat exchanger, so that heat will be exchanged easily from nuclear reactor to this heat exchanger component, heat exchanger component. Right. After heat exchanger, in heat exchanger, what happens is, whatever the heat energy which is passed through the heat exchanger. Okay, I mean, there will be water. I mean, you will try to fill the water. You will try to fill the heat exchanger with with the water. Next, what happens is, whenever I mean, inside the nuclear reactor, how the heat will be exchanged means, I mean, a coolant material will be passed from nuclear reactor to heat exchanger, and whenever the coolant material, whenever it comes from nuclear reactor to heat exchanger, I mean, it will be very hot. I mean, the temperature of the coolant material will be very high. Whenever this coolant material will come and it will enter into the heat exchanger. Okay, in heat exchanger, I mean, whatever the water is there, I mean, whatever the water is there which is surrounding the tubes of the heat exchanger, the water will get heated and it will turn into steam. Okay, and this steam will pass through the valve which is placed before the turbine. Okay, and it will move, and it will and through the opening valve of the turbine, this steam will move into the turbine. Okay, right. Right. Next is, what I have told till now. I have explained about nuclear reactor in detail. Along with that, I have explained about heat exchanger also in detail. And after that, from the heat exchanger, whatever the heat energy which is coming out, okay, we will try to pass it through turbine. Okay, right. From the heat exchangers, output will be given to the turbine through through a valve. Okay, and steam from the heat exchanger will enter into the turbine. Okay, and it will move the blades of the turbine. I mean again, turbines will be of different types. I mean axial flow turbine, radial flow turbine, based on the type of based on the manner in which the steam flows into the turbine, your blades of turbine will rotate. Okay, as the blades of turbine will rotate, then what happens is your thermal energy, which is your input to the turbine, your thermal energy has changed into mechanical energy, which is movement of shaft of the turbine, which is the output of turbine. And this turbine's output, which is mechanical energy, it will be given to alternator as input, which is which is alternator's input, which is mechanical energy. Next, at the end of the turbine, the leftover steam, or the steam which have the steam which was unable to rotate the blades of the turbine, or the exhausted steam from the turbine, it will be given to the condenser. Okay, as this exhausted steam will be given to the condenser, again your condenser component of the nuclear power plant, again it will have tubes in, again you have tubes inside the condenser component. Okay, the exhausted steam, again you will pass through the tubes of the condenser, pass through the tubes of the condenser, and again in condenser, around these tubes through which the exhausted steam is passing, around these tubes, you will try to circulate water by you will try to circulate water from a natural resource which is nearby. Okay, or you will try to use a cooling tower, and you'll try to you'll try to cool the water which is around your condenser, which is around the tubes in a condenser. Whatever the water is there, that water will be cooled by with the help of a cooling tower. Means the water will be extracted from the condenser and it will be given to the cooling tower, and this cooling tower will have the various arrangements which I have explained in a thermal power plant in detail, based on the type of cooling tower. Okay, the heat energy from the water will be extracted, and again the water with low temperature, or and again the cool water, which is the output of cooling tower, again it will be passed through the condenser, and this water will be circulated around the tubes through which the exhausted steam is allowed to pass. Okay, and again whenever this exhausted steam turns into liquid, and this is condensate extraction pump, again you'll try to take this condensate extraction pump, and again it will be circulated, and again this condensate again will be circulated into heat exchanger. In a heat exchanger it will be supplied, or it will be sent to the heat exchanger part of the nuclear power plant. And after that there is a coupler between turbine and alternator. In between turbine and alternator you have a coupler which is coupling turbine with alternator. Your alternator will convert mechanical energy into electrical energy, and again on the right side of the alternator you have another component which is called as exciter. What is exciter means? The rotor of the alternator, right, rotor of the alternator will be coupled to the shaft of the turbine. As the shaft of the turbine rotates, the rotor also rotates, but the rotor needs to have some excitation. Usually we give DC excitation for alternators. Okay, so we give a DC excitation for alternator, and that rotor of the alternator will rotate as it is coupled to the shaft of the turbine. Okay, right. Now mechanical energy will be converted into electrical energy by using in an alternator. Mechanical energy will be converted into electrical energy, and the output of the alternator will be given to transformer. Okay, right, from transformer, what transformer does is, usually the generation voltage will be 6.6 kilovolts or 11 kilovolts. By using a transformer, this 11 kilovolts will be stepped up. Okay, and through isolators and circuit breakers. Okay, This 33 kilo 11 this after stepping up from 11 kilovolts to 132 kilovolts or 765 kilovolts, it will be given to bus bars, and it will be transmitted from that nuclear power station to faraway distance. Again, at faraway distance where they are trying to use electrical energy, or where they need to when they need to distribute. Okay, so there again they will have isolators, circuit breakers, and transformers. And again at that transformer they will step down this voltage, and whenever the voltage comes to a normal level, I mean, whenever the voltage gets down to 415 volts like that, it will be given. I mean, direct line will be given to industrial applications. If why? Because they require three-phase supply, or if we want a single-phase supply means, each single phase it will be given to distribution transformer, and it will be supplied to domestic loads. Okay, this is the block diagram which is which explains detailedly about a nuclear power plant. These in this block diagram, all the components which are related to the nuclear power plant are covered. Almost I have tried to give an overview of the whole nuclear power plant in a proper manner. Okay, next from the next I mean each and every part in detail is explained in next slide. We will discuss each and every part in detail also, and then after that only we will go to the next topic. Right, next, how it works. See, just whatever I have explained, they have shown in a small block diagram type of model. Okay, they have shown the continuous procedure by using arrow marks. Nuclear fission makes heat. What is nuclear fission? Nuclear fission is a process in which a larger nuclei will disintegrate into a larger nucleus will disintegrate into a smaller nuclei. Nuclear fission makes heat. Okay, and this heat water, nuclear from the because of nuclear fission, heat is liberated, and this hot water is used. Or this hot water or the coolant which is coming from our nuclear reactor. This hot coolant is used to make steam. Okay, this hot coolant, whenever is passed through heat exchanger, it will turn the water which is there in the heat exchanger to steam, and again the steam will turn the turbines. Okay, the steam will run the turbines, and this turbines will run the generators, and this generators will be used for electrical power sent around the country will be done by this electrical generators. Okay, right, coming to the next part. This is the dome-shaped containment building at Sharon Harris Nuclear Power Plant. Okay, dome-shaped means it is in the form of, it is in this form, right? Okay, this is the dome-shaped containment building which is built at Sharon Harris. This is a nuclear power plant. Whatever they have shown, see, it is almost like an enclosed structure. Okay, and it is in dome shaped also. Right, what are the main parts? Just we will have a look at that. Okay, the main parts of a nuclear reactor are control rods, nuclear fuel, moderator, reflector, and coolant. Okay, these are the main parts, like how we have the parts in a thermal power plant, or like boiler, air preheater, like that. What are the parts of a what are the parts which are important or main parts of nuclear reactor means? You need to have nuclear fuel. Nuclear fuel is again separated by a moderator. Okay, you have control rods at the top of that rectangular structure, and you have a reflector material. You have reflector which is lined for that rectangular shaped box. Next, again you have coolant which is passed from this nuclear reactor to heat exchanger compartment. Okay, these are the main parts which are there in a nuclear reactor. Okay, right. In the next class, I will discuss about each and every part in detail. Every slide we will try to read about the parts and the components of the nuclear power plant. Okay, For today's class, I will end this topic till here itself. Thank you.